Okay, so in this section, we're going to talk about how to form a formula of an ionic compound with a polyatomic ion in it. Last time we were just talking about what do you do if you have just two monoatomic ions. So basically, if I have magnesium ion with a +2 charge and it bonds with the chloride ion with a -1 charge. Now we're going to be looking at molecules that have a charge as well. So when you have polyatomic, it's basically the same process. The tricky part really is that you have to memorize the polyatomics. I gave you two lists of polyatomics, and I also gave you a sheet called the Stealth Bomber. I'm going to go over that trick because that's going to help you memorize a lot of these formulas. Not every single one, but probably about 80% of it. Okay, so the Stealth Bomber works like this. So for the polyatomics that have oxygen in it, we can look at the periodic table and kind of tell what the formula and charge will be for a lot of those. Okay, so right here, consider this a plane. Okay, if the element is on the outside of the plane, if it's on the wings of the plane, when it makes an 8, so like carbonate, borate, nitrate, fluorate, when it makes an 8, it's going to bond with 3 oxygens. So borate, because it's on the outside, will bond with 3 oxygens when it's borate. If it was fluorate, it would bond with 3 oxygens as well. Chlorate would bond with 3 oxygens. If it's on the inside of the plane, it will bond with 4 oxygens. So phosphorus is on the inside of the plane. When it is phosphate, it will be PO4 instead of PO3. When you have sulfate, it would be SO4. Okay, so if you know this rule and you memorize what the other prefixes and the endings mean, then you can figure everything else out. So when you're looking at ites versus an 8, it's still going to be bonding with oxygen. It's just going to have 1 less oxygen than the 8. So if I have chlorate, it's on the outside of the wing, or outside of the plane, so it will be ClO3. So chlorite would have 1 less oxygen than this. It would be ClO2. If I had iodate, it's on the outside of the plane, so it would be IO3. So if it's iodite, it would be 1 less oxygen than that, so it would be IO2. Same thing for the inside. So on the inside, if it's an 8, it has 4 oxygens. So phosphate would be PO4. So phosphite would have 1 less oxygen than that, so it would be PO3. Same thing for sulfate. Sulfate is SO4 when it's an 8 because it's on the inside. And then when it's in sulfite, it's 1 less, it would be SO3. All right, now there's 2 other things that you need to know. You need to know about the hypo prefix. So hypo with the ending of ITE means that you have 1 less oxygen than the ite. So if I look at chlorine, when I have chlorate, it's on the outside of the wings, or outside of the plane, so it's going to have 3 oxygens, so chlorite would be 1 less than that. So hypochlorite would be 1 less than this, so it would be ClO. Okay, now hyper is the other prefix, and that means 1 more than the 8. So it would be hyperchlorate. So hyperchlorate would be, well, figure out what the chlorate is. If it's on the outside, it's going to be 3 oxygens. So hyperchlorate would be 1 more than this. It would be ClO4. And it seems like a lot that I'm giving you right now, this whole rule, and it might seem confusing at first, but trust me, it's better than memorizing all of the polyatomics. So remember, if it's on the outside of the plane or the wings, it's going to have 3 oxygens in the 8. If it's in the inside, it's 4. An ite will have 1 less oxygen than the 8. Hypochlorite will have 1 less oxygen than the ite, or 2 less than the 8. And hyperchlorate will have 1 more than the 8. Now the charges, simply look at the periodic table, most of them will match up. So chlorine has a -1 charge, so chlorate and chlorite and hypochlorite are all -1. Sulfate is a negative, or sulfur has a -2 charge, so sulfate also has a -2 charge. Nitrogen is the only one that's a little bit weird because nitrogen is a -3 charge, nitride, but when it's nitrate or nitrite, it's a -1 charge. But most of the other charges will just match up just fine. All right, so let's go ahead and go over how to write names and formulas. All right, so when you're dealing with ionic compounds, remember it's a metal and a non-metal. When you have polyatomics, it's an ionic compound. So if you see a polyatomic or if you see an H4, it's a polyatomic. So when you name it, the cation remains the same, so the positive one is always the same. So metal or ammonium remains the same, don't change it. Include the charge if you have a metal that has more than 1 charge, so like copper or iron would have more than 1 charge. And the name of the anion remains the same. So if you have a polyatomic, don't change the ending to that. Okay? Formulas, charges equal 0, or they add up to equal 0. And the cation is always first. Do not change the numbers of the polyatomics. So if I have a carbonate, it has to have CO3 in it. It cannot be CO2, it cannot be CO, it has to be CO3. And then also, you include parentheses if there's more than 1 polyatomic. All right, so let's name some of these. Okay, so first thing, you have to know these polyatomics inside and out. You'd have to be able to recognize them by sight. So when I look at this, I know that this is ionic because I've got K, which is a metal in it, and I've also got a polyatomic. So I know it's an ionic compound. Now, the cation or the metal, it's just the same thing. So it's just going to be potassium. Potassium is not a metal that has more than 1 charge. It's not the transition block. It's not tin. It's not lead. Then look at what's left. NO3 is what's left. You just have to know these by sight. Eventually, you'll just know them. So NO3 is nitrate. There's no trick to that. It's just memorization. Do not change the ending to anything else. All right, so now let's look at this one. Again, I've got a metal, I've got a polyatomic, I know it's ionic. So K is potassium. Don't change the name of this. It's not a metal that has more than 1 charge, so I don't worry about the number. And then the rest of it is NO2. So if I look it up, or once you know it, you'll know that that is nitrite. And do not change the ending. All right, the next one. Oh, I've already got a polyatomic right here. So I've got 2 polyatomics. NH4 is ammonium. I do not change the ending here. I do not include the charge because it's not a metal with more than 1 charge. And then whatever's left is CO3, and CO3 is carbonate. All right, so the next one, I've got Fe, and then, so I know this is ionic, I've got a metal in it. So Fe is iron. I look up iron on the periodic table, and it does have more than 1 charge. It can either be +2 or +3. So we need to look at the formula. Okay, so when I look at this, SO4 is what's left. So if I look it up, or you'll know it soon enough, it is sulfate. And then if I know the charge of sulfate, 1 sulfate, this whole thing right here, has a -2 charge. Well, I've only got 1 SO4, so that's -2, And then I know the whole thing here has to be 0. So the iron has to have a +2 charge. +2 and -2 would give me a charge of 0. So it would be iron 2 sulfate. I have to include that charge in it. Otherwise, I'm not sure, is it +2 or +3? All right, so CuSO4, Cu is a metal, so I know it's ionic. It's copper. If I look up copper, I know that it has more than one charge, so I need to figure out what the charge is. So let's look at the rest of it. This is the first part, which is copper. The second part is everything else. So SO4 is sulfate. SO4 has -2 charge, and there's only one of those. There's only one SO4. So the charge of the copper has to be +2 to make the whole thing equal 0. So it's copper 2. All right, so let's look at the next one. All right, so I know this is ionic. It's got a metal in it, so it's copper. I look at the rest of it. It's NO3, so that's going to be nitrate. And if I look it up, I know that copper can have more than one charge, so I need to figure out what that is. All right, so nitrate has a -1 charge. And there are 2 of those, because there's a number outside the parentheses. So that's -2. So the overall has to be 0. So -2 plus some number gives me 0. So it has to be +2. And because there's only one copper atom, each one has to be a +2 charge. All right, so let's look at some formulas. So let's put some of these formulas together. The main thing is, once you identify that it is ionic, so if it has a metal, if it has a polyatomic in it, you're looking at the charges and then you are switching. The main thing with polyatomics, you need to make sure that you do not monkey with the formula. If you have phosphate, if you have carbonate, you should make sure that you have that formula in there. So if it's phosphate, you better have a PO4 in there, otherwise it's wrong. It's just wrong. If you have carbonate in there, you better have a CO3. If there's no CO3, if you changed it to CO4, it is something else. You've invented a new compound. So you need to make sure that you do not monkey with that formula. All right, so first thing, let's look up calcium. Calcium is a metal. Oh, so it's ionic. I need to look at the charges. If I look it up on the periodic table, calcium's in group 2, so it has a +2 charge. Phosphate, well, hopefully you've started to memorize that. It's PO4. And it has a -3 charge. All right, so pull the Ca down. So remember, the metal or the positive ion always comes first. Pull the PO4 down. Pull it down as one thing. Pull that 4 down with it. All right, so now all you do is switch. Pull the 2 down here. Well, you've got a polyatomic, so you need parentheses. If you've got more than one polyatomic, you need to put parentheses around it. And then pull the 3 down here. So you have Ca3, PO4, 2. And the 3 and the 2 that I pulled down don't reduce, so I leave it alone. That's the formula. All right, so now copper 2, bicarbonate. Copper has, well, it can be more than one charge, and it tells you what the charge is here. So it's a +2. And I'm looking at the charges because it is ionic. It has a metal in it. Bicarbonate is HCO3 with a -1 charge. All right, so now pull the metal down, pull HCO3 down, the whole thing. And now switch. 2 comes down here. Oh, well, you need to put parentheses around it. The 1 comes down here, but you don't need to write that because it's improper. So it's Cu, parentheses, HCO3, 2. And a 1 and a 2 do not reduce. That's the formula. Barium acetate. Barium is a metal, so I need to look at the charges. Barium's in group 2, so it has a +2 charge. It's a coincidence. Acetate, it's one of those long, funky ones. It is C2H3O2 with a -1 charge. All right, so bring the barium down, bring the C2H3O2 down, and then switch. 2 comes down here, parentheses, and the 1 comes down here, which you don't need to write. So it's BA, don't need to write the 1, it's improper. C2H3O2, oops, parentheses, 2. And that's barium acetate. And 1 and 2, of course, don't reduce. All right, so ammonium chloride. Well, okay, ammonium is a polyatomic, so it is ionic. I need to look at the charges. Ammonium's formula is NH4 with a +1, and chloride is Cl with a -1 charge. Well, +1, -1, they cancel, so it should just be NH4 Cl. 1 of each, and that's it. All right, so potassium carbonate. All right, potassium's a metal. I need to look at the charges. So potassium's +1. Carbonate is CO3 with a -2 charge. All right, so bring the metal down, bring the CO3 down. The 1 comes down here, but you don't need to write it. And then the 2 comes down here. So it's K2CO3. All right, so 2 and 1, I can't reduce that. And remember, if you're reducing, you're never ever going to change the polyatomic formula. So if you have carbonate in your name, you should have a CO3 in there. Otherwise, it's wrong. All right, and we're going to do lots of practice with this. And next time we're going to talk about acids and covalent compounds.